Okay, so today we're going to talk about aldehyde and ketones. And aldehydes and ketones both have a carbonyl group. So they have a C that's doubly bonded to an oxygen. If that C double O bond comes at the end of a chain, that is designated an aldehyde. Ketones, however, have a C double O bond in the middle of a chain or in a ring. So let's talk about how to actually name this. If you have a C double O bond at the end of a ring, that's an aldehyde, and we end the chain name with an AL. So instead of having like pentane, you would have pentanal. That C that's involved in the C double O bond is going to be number 1. So I would start my numbering here if that were to occur. And that's understood. You don't even need to write that in. But just think if you want to, that's perfectly fine too. So this is simply butanal. Now keep in mind that the carbon that is attached to that oxygen also counts in this chain. So that's 1, 2, 3, 4 carbons, okay? Here we have a 1, 2, 3, 4, 5 membered ring. And this is going to be number 1 because it's where the C double O bond is located. So this is 1, 2, 3, 4 is where that fluoro is. Before fluoro, pentanal. You can't actually name that as an aldehyde. You can't name that as an aldehyde because it's not the end of a ring. So there is no such thing as a cyclic C double O bond, at least where the carbon is included in that ring itself. Now ketones are very similar to aldehydes, it's just that they are inside, excuse me, inside the chain rather than being on the end. You can also use them to name the cyclic versions that have a carbonyl in them. Here we're going to take out the E at the end of the chain name and put one. Now that's O-N-E, not one, own. Okay, so here we go, 1, 2, 3, 4 carbons. In this case, we do need to tell people where that carbonyl is located, and we want to have that at the lowest possible number. So we can count from this side, or we can count from this side. But if we count from this side, that C double O bond gets number 2. Therefore, this would be simply 2-butanone. Even if you have something way out here, he gets the priority because he gets the end of the name. So here we go, 1, 2, 3, 4, 5, 6, 7, 8. That becomes 8-chloro, 3-octanone. Now we have a ring. In this case, he's going to be number 1. That's understood again. I'm going to move to the right one, and that's going to be number 2. So it will be 2-methylcyclopentanone. Again, if you don't want to put a 1 there, you certainly don't have to, it's understood. But if you want to, feel free. Excuse me. Now here's where things can get a little bit more interesting. What if you have 2 functional groups? This is not very common, but it does happen sometimes. In that case, you have to figure out what your priority is in naming. The highest priority is going to be that of the aldehyde. One way to remember that an aldehyde is a higher priority than a ketone is that the end of the word would end with an al, and that simply comes first in the alphabet. Alcohol would be the last in this series of prioritizing. If you're listing OH as a substituent, because you've got an aldehyde there that takes higher priority, it becomes a hydroxy group. If you have a C double O bond that you are listing, it becomes an oxo group. Let me show you what I mean, because that's not quite as clear. So you see how in this example, we have both an aldehyde and a ketone. Well, let's look back at our priority list here. It tells us that aldehyde's the top of the list, and then we have ketone and alcohol, which means that the aldehyde is how we determine how we're going to name them. So that is known as an aldehyde. That's where number 1 is. And then we name this as a substituent. The C-double-O bond is an oxo. So it becomes 1, 2, 3 oxo hexanal. Okay, let's try another one. Here we have an OH for an alcohol and a C-double-O bond as a carbonyl. Well, this guy's a ketone, that's an alcohol. Looking up here, ketone is a higher priority than an alcohol. So this is going to get number 1 in the end of the word. Therefore, this is my substituent, and that's what goes at the beginning as a substituent. And that's what I mean where OH could be hydroxy. So this becomes 2-hydroxycyclopentanone. And here we have an aldehyde and an alcohol. So between these two, an aldehyde is going to take the highest priority. It's going to be number 1, 2, 3, 4, 5. This becomes 5-hydroxy, 3-methyl. That's fine if there's one of those stuck around. Octanol. Got to be really careful with the end of the words when you're going from a name to a structure, because those little letters right there at the end can completely change the structure, so make sure you check those. Okay. Now, carbonyls are flat, but they also have polarity to them, which means that they can, it's going to affect their intermolecular interactions and physical properties. They're going to be involved in dipole-dipole bonds, but they cannot hydrogen bond. Therefore, their boiling points are going to be sort of in the middle. It's going to be higher than that of an alkane or an alkene, but they can't hydrogen bond, so they're not as high as an alcohol. If you look at the solubility of a particular compound, things that have more of the C-double-O bond nature, so not very many carbons listed, these are going to be more soluble in water. This is really a spectrum, something that has a whole bunch of carbons, not so soluble in water, but much more soluble in nonpolar solvents like hexane. And that's it.